And we are done. This whole complexity, this complexity is very complex. Okay, let's do some math for fun. Today I got two integrals, and as you can see there are a lot of 2020s except this part, because this part I got 2019s here. Well, you will know why later, but in this video I will going to do something that is related to 2020s, because this year is 2020s, and I decided to do some calculus, which is, yeah, I'm making this video right now. So as always, if you guys interested in this question, pause the video and try them for yourself. Okay, let's solve this question first, because if you guys really try these two questions, these two integrals, you already know that this integral is much easier than this integral, because x to the 2019's power is just basically the derivative factor inside the function x to the 2020's power plus 2020. So because x to the 2019's power is the derivative factor of x to the 2020's power plus 2020, we can just basically do some simple u substitution. So I will let u equal to x to the 2020's power plus 2020, then du is equal to now the derivative of a constant is always 0, but when we differentiate x to the 2020's power, we will take this 2020 to here, and at the same time the exponent is -1, so we get 2020 times x to the 2019's power dx, and finally we will solve for dx, which is equal to 1 over 2020 times x to the 2019's power du. So what we can do is we can just substitute u to here and dx to here. So basically what we can get is equal to the integral of x to the 20. Okay, maybe this space doesn't enough, so I will write to here. So I will get the integral of x to the 2019's power times u times u to the 2020's power times 1 over 2020 times x to the 2019's power du. And look at what we got here. The 2090s and the 2019, they can basically cancel out, right? They can basically cancel out. So what we get is equal to the integral of u to the 2020's power over 2020 du. So what we can do is we can just literally integrate, because if you know the integral of x to the n's power dx, well, we can just do simple integral, which is going to be equal to u to the 2021's power over 2021 and multiply by 2020, because I got some constant right here, and then no, not du already. Then I need to plus c, but wait, because I have to undo the substitution, x to the 2020's power plus 2020, so which is equal to x to the 2020's power plus 2020 to the power of 2021 over 2021 times 2020. What is it actually? So 2021 times 2020. So that's 408240420. So 4082420, and don't forget, because it's indefinite integral, we can just plus c, and we are done the first question. Okay, now let's do the second question. As we can see, when we compare this question, this integral to this integral, what we can see is there's no derivative factor. And in fact, in this kind of situation, for this integral, we have no choice but to expand. But don't go too far first, because expressed in exact form, which means that when you are expand, you are going to expand every single term in this expression, and then you are going to integrate every single each of them. You don't want that, right? Because they will take like hours or even days to even complete just for one integral. So we don't want that. So what we can do now, little fun fact, if we expand this, we will get 2021's term, and because it is the indefinite integral, we have to plus c, so that's a total of 2022 terms. So what we can do is, now, did you look at this power? This power is 2020. 2020 is a natural number, and inside this power of 2020, I got x to the 2020's power plus 2020, which is a total of 2 terms. So this tells us what? This tells us that we could use something called the binomial theorem. So binomial theorem. So what does binomial theorem tells us? So if you have a plus b to the nth power, and this is nicely equal to the sum of r goes from 0 to n of NCR times a to the n minus r power times br, or you can have b to the n minus r times ar because of the commutative property of addition. So we can use this binomial theorem, and in fact, because n is involved in the limit of the summation, what we can say is n must be a natural number. So n must be natural number, because if you know how the summation works, well, good for you. So we will use this binomial theorem, plug it inside this integral. So what we're going to do is now, in this case, the a is equal to x to the 2020's power and b is equal to 2020. But wait, what about we let b equal to x to the 2020's power? Because if you do inside your mind, that's like more easier to integrate, right? The integral method is still same, but you want to make it more simpler. So what we can do is we will let this equal to b and this is equal to a, and a plus b is same as b plus a because of the commutative property of addition once again. So what we can do is this thing is nicely equal to, let me just write down here, the integral of the sum of r goes from 0 to n. What's the n? 2020. So 2020 of 2020 CR times b. What's b? Well, I say b, but let me say a first. So it's equal to 2020 times 2020 minus r times the b, which is x to the 2020, now by law of indices, r, and then this whole thing dx. Let me just draw the integral sign bigger. So here's the problem. how can we integrate a series, because we normally do some this little x or some natural log or maybe even trigonometric function, but we never do a series. So how are we going to do a series? Well, we are going to take this whole thing. Let me just use the black one first. Let me just use the black one. We will take this whole thing to outside this integral. So this integral is nicely equal to the sum of r goes from 0 to 2020 of 2020 CR times 2020 minus r times the integral of x to the 2020s times r's power dx. Well, we can just do some simple integral. So this thing is going to be equal to, and in fact, since we got two variables, but don't worry, we will treat x as the variable that we need to be integrated, and r is a constant. So this is going to be the sum of r goes from 0 to 2020 plus c, and we are done. This whole complexity, this complexity is very complex, but we have done it somehow, and this is really nice because we actually express in exact form, but we just use summation to simplify this whole thing. So I hope you guys learned something in this video, and if you guys enjoy this video, leave a like and subscribe for more math videos, and I will see you guys next time.